Before we get to those three word problems, a quick overview here. The only thing that is different, well, there's a couple. One of the things that's different here is when you look at something like 8b, it has fractions. So what you want to do is eliminate the fractions somehow. You would do that in 8b by multiplying both sides of that equation by 4, or if you like, multiplying every term in the equation by 4. Okay. The other thing that's different is sometimes you have, I don't see any here. None of these problems have decimals, but if you did have decimals, you can multiply everything by 10 or by 100 or by whatever factor or power of 10 is necessary in order to eliminate all of those decimals. The other thing that's different is a difference of squares. So if we start off with 8a, you can factor a 10 out of the expression that's equal to 0 in 8a and have left n squared minus 4 equals 0. Again, we even talked about this morning in a different class in Math 30-1. Can you get rid of that 10? Can you divide both sides by 10? Yes, you can. Do I want you to? No, I do not. I want you to leave it there. Okay. What we are going to do, though, is factor this as a difference of squares. So this is, well, it was new to us in terms of solving quadratic equations, but factoring a difference of squares should not have been new to you yesterday. You do that in grade 10. And then you have three factors. Any value of n that makes any of those factors 0 is a solution to the equation. You don't have to worry about the 10 because, as we said yesterday, 10 is not 0. It can't be 0. But n plus 2 can equal 0. And n minus 2 can equal 0. And again, we're back to, at this point, we're back to before spring break, basically. And at this point here, we're back to before you even started high school, right? And you can solve that. So does anybody have any questions from any of the problems from 8, 9, or 10? So these problems would revolve around algebra. What are the steps you use to get to the solution? All right, so I'm going to set up the three word problems. This is the application part of the math, and this is the part that can be challenging. You know how to do the math, but when you have to build the math equation, sometimes it's more complicated. So you have a rectangle with dimensions x plus 10 by 2x minus 3. X is some number of centimeters, and the area is 54 centimeters. Well, you should know, you shouldn't need to be told this, that area of a rectangle is length times width. So if we start off with that idea that area is length times width, we can set up an equation to solve. The area is 54. The length is x plus 10. The width is 2x minus 3. All right, so this is the length. This is the width. And this is the area. Right? Area equals length times width. So this equation, everybody, this equation, looking at it, how many of you see it's going to be quadratic? Why is it going to be quadratic? This is an important question to know the answer to. Why do we know this equation is going to be quadratic? Yeah. Right, it's going to have a term with an x squared in it if we expand it out. And this goes back to almost, this next bit of business goes back to when you're first kind of taught about equations that get more complicated. You always want to simplify things before you start to solve them. And in this case, we can multiply this x plus 10 by 2x minus 3. I have a question for you, though. Just clear your mind of everything that we've talked about in getting to this point. Can somebody tell me why, if you wrote this out and then you said, oh, x is negative 10 and x is 3 over 2. Do you see where I'm getting those numbers from? Why is that wrong? Say that again?
It's not equal to 0.
It's not equal to 0. That trick only works when it's equal to 0. In order for us to find out what the numbers for x actually are, we have to set this equal to 0 and expand everything out. So I'm going to have to, quote, FOIL this out. X times 2x, which is my first. I'm doing first, outer, inner, and last. I'm going to have 2x squared. My outer is minus 3x. My inner is plus 20x. And my last is minus 30. Just keep me on my toes here and double check my multiplication there. Okay, this is not equal to 0. It's equal to 54. But now we look at it. This is where the light goes on in your head. You go, oh, it's quadratic. What do you do with every quadratic equation in the universe, with the odd exception? You zero it. So we get 2x squared. I have plus 17x. Negative 3x plus 20x is 17x. I have negative 30, and I have to subtract 54, which is negative 84. And this is equal to 0. Well, that's really a little unfortunate. This is one of the ones that I'm going to actually complete all the way. Is this factorable? The reason I say it's unfortunate is because the coefficient of the first term is not 1, so it's kind of a complicated thing to factor. And we got some pretty big numbers in there to grapple with. So I would, if I were you, determine if this is factorable or not. We can do our b squared minus 4ac test, and round about maybe Thursday or Friday of next week, you will learn why this test works. There's a reason for it. So grab your calculators, and we need to figure out what 17 squared minus 4 times 2 times negative 84 is. What is it? 961. But 961, I screwed that up in my head. I was thinking 700 something. That's a perfect square, isn't it? Is it 19 squared? 31 squared. Okay. 31 squared. So it's a perfect square, which means this is factorable. Well, now we can waste our time, not waste, but now we can put our sweat and tears into this and get a solution. It won't be a waste of time. This would have to be 2x and x. Now, the 84 is the troublesome part. I'm thinking 4 and 21, but I could be wrong. Okay. If I say 4 and 21, I have to put the 21 here, because if I put a 4 with the 2x, I create a common factor of 2. I don't think this is going to work, because my outer is going to be 8x, my inner is going to be 21x. That's not working. Okay. A little tip for you. If you know that 4 and 21 multiply to give 84, and they do, don't they? Then you also know that 12 and 7 do. And the reason why that's the case is if I divide this 21 by 3 and multiply the 4 by 3, I still have all of the same numbers being multiplied together. So 12 and 7. If it's 12 and 7, then I cannot put the 12 here, because if I do, I'm going to create a common factor of 2 in that binomial. So I'm going to try to put the 7 here and the 12 here. And in the time it took me to say that and write that, I see that this is going to work. Because my outer will be 24x. This is my outer. My inner is 7x. And if I make that 24x positive and the 7x negative, then they will add to give positive 17, which is what I'm after. So I want this to be positive and this to be negative. How do I get the positive 24? I need positive 12 here and that. would be negative. Are we okay with the factorization there? Can you just take a moment, FOIL it out, just confirm that you are going to get 2x squared plus 17x minus 84? And what you're doing, what I'm asking you to do, is something you should always do before you commit to it. All right. I had a conversation with Owen and a couple of other people yesterday that I don't care. I don't care how you get from here to here. There's no work ever that needs to be shown, ever. So if you want to use some method that you're aware of, or you just want to use trial and error, that doesn't matter. We're long past the stage where you're learning a method. You have to know how to do it. So that means x plus 12 equals 0, and 2x minus 7 equals 0. X plus 12 equals 0 gives us this for x, and this gives us 7 over 2. Just roll that around in your head. Make sure you know how I'm getting 7 over 2 here. And understand that you would show at least one more step on an exam, on a written response there. Why? Well, let's talk about the negative 12. If x is negative 12 and I put x in here, I'm going to get a negative length of negative 2. Do you see that? Well, you can't have a negative length, so x can't be negative 12. This is what we're going to end up calling an extraneous solution. It's a solution that you get using the math perfectly, but it's just not a correct solution. The other one is 7 over 2, which is 3.5. Well, let's just check something else out here. What equation could we use? We've done that. What is the value of x? 3.5. Craig, what do we get when we take 3.5 plus 10? 13.5. So this is 13.5 in here. What do we get if we take 3.5 times 2 and subtract 3?
4.
Excellent. You get 4 here. Let's check something out. Is 13.5 times 4 giving you an area of 54? Yep. You don't need to check. If you're confident in the math, you're done. But anyway, that's the answer to 11. Let's take a look at number 14, the product of two consecutive even integers. Okay. Integers are the following numbers. Right? They're positive or negative whole numbers, and whole numbers include 0. Even are these. 4 would be even, negative 4 would be even, 6 would be even, negative 6 would be even. In order to start this, you have to say to yourself that x is going to be an integer. Well, I better be more precise here. An even integer. All right? So, I mean, you have to introduce a variable. The next even integer and it's the next even because it says they're consecutive even, one after the other. So maybe one of the integers is 8, the other one is 10. Maybe it's negative 6 and negative 4. The next even integer, everybody, is x plus 2. Because the even integers are separated by 2. If it just said 2 consecutive integers, then you would say x and x plus 1. What are we told about these two numbers? Okay, so I don't... You've had so many math teachers over your math education. And so many different ways that things are taught, but I'm just going to teach you how to convert that English sentence that I've highlighted into a mathematical equation. It says the product, okay, the product is this. Product means multiply. is, very important, I don't know if anybody's ever told you this, the word is in English means equals in math. If I say my age is 35, as well as lying to you, I'd be claiming my age equals 35. Is means equals. Equals 16 more than. 16 more than means we're going to add 16 to something. More than what? More than 8 times the smaller integer. And there's the equation that we need to solve. I know I said I probably am not going to solve all of these, but I do want to solve this one as well. Okay? So we expand this out. X squared plus 2x equals 8x plus 16. You immediately see an x squared, so you say it's quadratic, which means I zero the equation, which is going to give me x squared minus 6x minus 16 equals 0. I don't think we need to do the b squared minus 4ac test here. I mean, are there two numbers that multiply to give negative 16 and add to give negative 2? Negative 6, rather. 8 and 2 will do it, won't they? I mean, we'll have to figure out where to put the negatives, but it's 8 and 2. I guess we want the 8 to be negative so that we end up with negative 6x. Are we okay with the factorization there? Okay. There are two solutions here. X equals 8, and I hope you'll forgive me not writing x minus 8 equals 0. We're not going to do that here. And x equals negative 2. Would you agree those are the solutions? Okay, listen to my words. There's two solutions to this equation, so there's two solutions to this problem. One of the solutions is the first integer is 8, and the second would have to be 10. 2 more than 8. Let's check something out. We were told the product of these had to be 16 more than 8 times the smaller one. Is that true? 8 times 10 is 80. If I take 8 times the smaller and add 16, do I get 80? Yep. Okay. This is an answer. The integers are 8 and 10. But we said x equals negative 2. Let's check this out. If x equals negative 2, then the next integer would be 0. Right? Negative 2, add 2 to get 0. Let's check this out. The product of these should be 16 more than 8 times the smaller number. Negative 2 times 0 is 0. Is 8 times the smaller number plus 16 also going to give you 0? We have two answers here. The integers are 8 and 10, or negative 2 and 0. Now, I haven't looked, but we do need to look, because sometimes it says two positive consecutive integers, in which case that narrows it down. What does it say, though? It just says that. Now, I don't know. Your textbook sometimes doesn't do things exactly the way they should. The answer should be, there should be two sets of answers in the back. Are there? Does anybody know? There are. Good. Because sometimes they'll only put one for some reason. All right, and 15, the area of a square is tripled by adding 10 to one dimension and 12 to the other. So if we have a square, let's just call the length of each side of this square x. we're going to triple one of those dimensions. We're going to add 10 to one of those dimensions and add 12 to the other. Is it clear it's not going to be a square anymore? It's going to be a new shape, and the new shape will be this is not going to be drawn to scale, okay? Because quite frankly, I don't know what x is. Does that make sense? And this area of the large rectangle is 3 times the area of the other one. Well, the area of this is x squared. The area of this is x plus 12 times x plus 10. Just ponder that. This area is 3 times this area. And there's your equation. I'm going to do one more step, but then we're going to move on. Before I zero this, I need to expand everything. Can you double check my mathematics there, my arithmetic? My algebra, I guess, because there's x's involved. So you would zero this equation and then factor it to solve. I'll leave you with this idea, though. I'm going to go out on a limb here and say that when you factor it and solve it, you're going to get 2 answers. One will be positive, one will be negative. Since x is a length of a side of a square, you're going to kick the negative number over the boards and not use it. All right, we're going to move on now. This is the 4th part of section 4.2 in your textbook. I want to make something very clear from the outset before I talk about any of the content here. We're not solving equations today. We're only factoring. If you were to look at all of the examples, there's no equals 0 there. There's no equation. It's just factor, 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 factor. This is all about factoring, but you don't know how to factor these ones yet. I haven't shown them to you. What we are looking at doing today is factoring quadratic expressions of this form. And I have a typing mistake on mine, which you do not have on yours. There's a squared there, right? What does this mean? Don't get psyched out over this. This looks, and there's a squared here. For some reason, I've lost them. This looks complicated, but it isn't. It's just saying the following. If I say to you, factor this, I hope with just maybe 5 or 10 seconds of thought, you would say, I need 2 numbers that multiply to give negative 40 and add to give negative 3 would be negative 8 and 5. Am I right? Okay. There's no x equals negative 5 and x equals positive 8. It's not equal to 0. We're not solving it. I'm just talking about factoring. Okay, so I don't think anybody would be thrown off if I said, factor that. Ooh, it's not x, it's t. That's pretty easy. It would be t minus 8, t plus 5, right? Does that make sense? Okay. What if, just because, I gave you that to factor? And the point I'm trying to get across to you, keep this in mind, is that when we do math, math is very symbolic on paper when it comes to algebra. So the fact that we write an x just means it's a thing, and we're calling it x. We could call it t. I'm calling it a club, like from a deck of cards. So club squared minus 3 club minus 40. It still fits the same pattern as this, doesn't it? And when we factor this, you say since it's x squared, I put an x here and here because I want to get x to the 1s on my outer and inner. And that's then when we say, well, I need -8 and 5. That's the process that we go by. So if I say to you, factor this, you're going to do the same thing. You're going to put a club here and a club here, and you're going to say what two numbers multiply to give -40 and add to give -3, -8 and 5. And it doesn't matter what that thing is that's squared and what that thing is that's being multiplied by -3. What does matter, and it's what makes this quadratic, is the exponent on the thing in the first term is even, and the exponent on the thing in the middle term is half the exponent on the thing in the first term. Okay? And then there is no variable in the third. Well, what if I said this? Go ahead and factor this. Puppy squared minus 3 puppy minus 40. Well, you would say to yourself, in order to get puppy squared, whoops, I need to put puppy here and here. That will give me my puppy squared. In order for me to start getting puppies for the middle term, I need numbers elsewhere. And I know that many of you get this already, but it's going to get confusing. Just ask yourself what you would get if you expanded that out. You'd get puppy squared, wouldn't you? Would you get -40 at the end? Would you get -8 puppy plus 5 puppy to give you -3 puppy? Okay, so I don't want to, belittle mathematics, but on some level, a lot of math is just squiggles on paper. They represent things, but they're just marks on paper. If I said to you, factor this, it'd be the same thing. I don't quite know what to call that image, but you would put it here and you would put it here. Well, that's weird. Do you see what happened there? When I pull it off, the lines are vertical, and then when I let go, they go horizontal. I'm sorry, I'm easily distracted sometimes. And then you would say what numbers multiply to give -40 and add to give -3, right? When we go back and look at this notation, and because it's going to bother me and I would like to fix this for next time, give me a second to do so. Maybe I can't. There we go. I guess I'll have to fix it later. There's a 2 here and there's a 2 here. All this is, everybody, is factoring stuff that falls into this realm. A times something squared plus B times that thing plus C. That thing could be puppy. It could be, that thing could be x squared. Think about that for a second. That red thing could be x squared. In other words, the first term will contain an x to the 4. Could be anything, as long as the first term has something squared and the second term has that thing to the 1. So let's put this into action. Factor the following. So what this is like, and I want to show you how we can set this up in our head, but I don't want you leaning on this crutch all the time. If we imagine, if we let, I don't know, r be 2x plus 5, then this thing to factor would be r squared minus 3r minus 40, wouldn't it? You see what I'm saying here? You can factor that. So why can't you factor this? Why can't you just say this is going to factor into 2 binomials, and it's not r squared, it's not puppy squared, it's not club squared, it's 2x plus 5 quantity squared, which means I have to put a 2x plus 5 here and a 2x plus 5 here. And then I say, well, what are two numbers that multiply to give that negative 40 at the end and add to give negative 3? Well, it's the same as the ones we were using before. This is minus 8, and this is plus 5. Now, before we go on, think of this 2x plus 5 as a single thing. Let's just FOIL this out. Will we get 2x plus 5 quantity squared for the first? Yep, it's 2x plus 5 times 2x plus 5. Will the last, which is the product of this and this, give us negative 40? Yes. Will my outer and inner combine to get negative 3 2x plus 5s? Yes, because my outer will be 5 of those 2x plus 5s. My inner will be negative 8 of those 2x plus 5s. And that gives me negative 3 of those 2x plus 5s. Some of you are going to discover an alternate way to get to the answer here. If you do, I want you to not do it. Okay? There are other ways we get to the answer. You need to know how to do this factoring. Well, man, we don't walk around saying 5 plus 5. We say 10, don't we? And 5 minus 8, why don't we just say minus 3? So what we end up with is 2x minus 3, 2x plus 10, which is a factored form of the original expression. Are we done? Why not? There's something you're taught about factoring in grade 10. What do we have to do at this point? Any ideas?
Check for common factors.
Right. And the second factor of 2x plus 10 has a common factor of 2. So we can take that 2 out. Now we have 2x minus 3 times 2 times, when we take the 2 out of 2x plus 10, we get x plus 5. And most people would write that 2 that we factored out in front. Now, the thing you're taught in Math 10 about factoring is you have all these different ways to factor. When you get to the end and you think you're done, ask yourself if there's anything else you can factor. There wasn't a common factor to begin with. We couldn't see it, but there is now. So that's the answer to this question. Let's try another one. All right. So we're going to think of this. Just allow me the liberty to just do this for the time being. We are going to think of this as 5 blob squared minus 5 blob minus 100. Could you factor that? If this were, for example, 5x squared minus 5x minus 100, could you factor it? Yes, this is what we did yesterday and the day before. What would you do first if you were going to factor this? Hold on. Sorry, Craig. Factor out the 5. So you might want to just not write anything down just for a second. I won't rush you. We'll have time to write it down in the end. But if you did that, then you would end up having 5. And then you would have, I'm going to go with the blobs. You would have blob squared minus 5 blob minus 20. Whoops, minus 1 blob minus 20. Would you agree that's factored correctly? I'm just taking a 5 out of everything. If it makes it easier for you to see what I'm talking about, If I took 5 out of 5x squared minus 5x minus 100, I'd have x squared minus x minus 20. Are we in agreement now? Okay. Well, what would you do then? Well, then you would have 5. And what would we put here and here? Well, you'd put this blob, or if you want, x. It doesn't really matter. And I, by the way, be very clear. I'm not saying this is how you're going to do these problems. I'm trying to show you that you know how to do them. And then you would say what two numbers multiply to give negative 20 and add to give negative 1. That's negative 5 and positive 4, right? Okay. Well, let's give our heads a shake and come back to reality. It wasn't 5x squared minus 5x minus 100. It wasn't 5 blob squared minus 5 blob minus 100. The thing that was squared and the thing that was raised to the 1 in the middle term was 3x minus 2. So that's what goes in these places. And I hope after saying all of that, you understand how we go from that first line to the middle line. I'm factoring a 5 out of each of those terms. And then what I do is I say to myself, since this coefficient is 1, I can put that thing, 3x plus 2, here and here, and put in the two numbers that multiply to give negative 20 and add to give negative 1. And then we can clean this up. This is 3x plus 6, and this is 3x minus 3. Yeah.
How does it go from 3x minus 2 to 3x plus 2?
I don't know. Thank you. Let's change that. I don't know because I can't tell you what my brain did there. Sometimes my brain is inaccessible even to myself. It is 3x minus 2. Thank you, Gustav. So it's 3x minus 2. Good catch. This becomes 3x minus 2 plus 4 is plus 2. This becomes minus 7. Or is that better? Okay, thank you for pointing that out. Any questions with that one? And by the way, we're done. No common factor, no common factor. Let's try another one. Okay, I think we're done with the blob thing and the substitution thing. What, if I were to factor this, what would I have to put here and here, and wait for the whole question? It's a long question. What would I have to put in each of those spots so that I could get x to the 4 for the first term and get x squareds for my outer and inner combined? What would have to go in that green cloud? Do you know, Charlie? X to the 2, x squared. Here's this thing I was talking about, that the exponent on the first term is even, and the exponent on the middle term is half of the exponent on the first term. Now, what are the two numbers that multiply to give 36 and add to give negative 13? Well, they would have to both be negative, so that's what it factors into. And I want you, again, everybody, to explore in your mind what you get if you FOIL this out. Convince yourself that you're going to get x squared minus 13x plus 36. So that's the answer. Are any questions with that? Is that the answer? Owen?
Can we factor further?
Yeah, they're both differences of squares. X squared minus 4 is a difference of squares. We can factor it into x plus 2. x minus 2. We can factor this into x plus 3, x minus 3. And by the way, even though we're not doing this today, you now have the skills to solve some degree 4 equations. The solutions to this equation, which I don't want you to write, would be negative 2, positive 2, negative 3, positive 3. I say some because not everything is factorable. Right? Well, there's a common factor of 2. Let's take the 2 out. And leave x to the 4 minus 5x squared minus 24. How's my arithmetic there? Think it's okay? Is the exponent on the variable in the first term even? Is x raised to an even number? Yeah. Is in the middle term, is x raised to half of the exponent in the first? Yes. And in the last term, are there 0 x's? Yes. That means it's quadratic. We can put x squared here and x squared here. By the way, the b squared minus 4ac trick still works here. It's just, for kicks, calculate b squared minus 4ac. I'm pretty sure that's 121. It's a perfect square, so it's factorable. So what two numbers multiply to give negative 24 and add to give negative 5? I think that's it. Nope. I think that's it. Double check something. Is x squared minus 8 factorable? Nope. It's not a difference of squares. Is x squared plus 3 factorable? No. So we're done. Once you start to get into the groove here with the pattern, it makes sense. Is there a common factor in E? Sure, 2. Let's factor the 2 out. And the reason is when you factor things out, you end up with smaller mathematical expressions to deal with. Smaller numbers. Is anybody willing to give me an explanation why this is quadratic? Why is this quadratic? I mean, it is a degree 6 polynomial, but we think of it as a quadratic. Why is that? Charlie,
Bucket says it's equal to 0.
can you start again?
And the bucket says it's equal to 0. Does that mean you can
Oh, in the book it's equal to 0?
Yeah.
Just cross that out. That's a typing mistake. I'll have to fix that. So why can we consider n squared plus, or n to the 6 plus 4n to the 3 minus 21 to be quadratic? Aoki? A little louder?
The first exponent is double the second one.
The first exponent is double the second. Perfect. And since exponents are always whole numbers so far in your high school math, that means if the first is double the second, the first is even. So 6 is an even number, half of 6 is 3. How many of you understand that the reason this is going to work is because n cubed times n cubed will give us n to the 6. And then if we put numbers in the other places, you're going to get numbers times n cubed, which will fill up the middle part of our polynomial. So what two numbers multiply to give negative 21 and add to give 4? Plus 7 minus 3. And that's it. Before we do the next one, I want you to notice that for this one, the coefficient of the quote quadratic term was 1. For this one, the the coefficient of the quadratic term was 1. So that was before spring break kind of thinking. What two numbers multiply to give negative 21 and add to give 4? Can we factor that 5 out? No. So this is after spring break factoring. We know that whatever we put in these two places has to multiply to give 5y to the 4. Well, that's going to be 5y squared and y squared. Question for you. I want everybody to think about this. Why would it never enter your head to do something like this? That's going to give you 5y to the 4. I mean, it just doesn't look right. I understand that. But what's wrong with it? Why wouldn't that even be something we could pursue? Aoki?
When you do the inners and outers.
Right. When you do the inner and the outer, this is always the first, this is always the last, and this term comes from the outer and inner added together, right? But if I do this and put numbers in the other places, my outers will be y's, my inners will be y cubeds. That's not y squareds. And that's why you have to split that middle term, or sorry, split that first term in terms of variables down the middle. If it's degree 6, you have to have cubed and cubed. If it's degree 4, you have to have squared and squared. Two numbers that multiply to give negative, oh, sorry, this is trial and error, right? Because the first term is not 1 times something. So would you agree these are probably 2 and 4? Those would be what you would try. Okay, I'm going to write them down in that order. I'm going to try a 2 here and a 4 there. Very quickly, how many of you see as quickly as I just did, this is not going to work? Because my outer is a whopping 20y squared. And my inner is only 2y squared, but I need to end up with 3. So I'm going to switch these around. Is that going to work? No. Does that mean it's not factorable? Well, no. Because as many times as I've said, it's probably not 1 in the number. It's probably numbers that are closer together. I've always said it could be 1 in the number. And I think if you put 8 here and 1 here, you'll be able to finagle a 3y squared out of that deal somehow. If I make this negative 1 and positive 8, what do I get for my inner and outer? My outer is negative 5y squared. My inner is positive 8y squared. That pleases me because I want positive 3y squared. Are we done here with this question? We're not done here because y squared minus 1 is factorable. It's a difference of squares. You always got to watch out for that. It's 5y squared plus 8, and then y plus 1, y minus 1. Questions with F? I don't know why this is lettered I in your handout, but I'll fix it for next time. There is no G and H. It goes just from F to I. Can I take a common factor out of this? Remember, we're asked to factor everything. Is there a common factor? No. Does this fall into the A times a thing squared plus B times a thing plus C category? Yes, it does. The thing is q cubed. This is what I meant by A times a function of x, quantity squared, plus b times a function of x plus c. It could be a puppy squared plus b puppy plus c. It could be a times q cubed squared plus b times q cubed plus c. It could be anything. So we're going to dive right in and factor this by trial and error, or inspection if you like. This must be 3q cubed. This must be q cubed. How many of you now are pretty comfortable with the idea of why they have to each be q cubed in order to make this work? Because when I FOIL it out, I need q cubes for my outer and inner. Since the coefficient of the first term was not 1, we can't just put in the numbers and walk away from the question. It's a trial and error kind of thing. 6. Okay, well this is interesting. If it's 6, and by the way, do you see these have to both be negative? We have to multiply to get positive 6, but we have negative middle term. It's probably going to be 2 and 3. And if it's 2 and 3, the 3 cannot go with the 3q cubed, so that must be 2 and this must be 3. Is that correct, though? My outer is negative 9 q cubed. My inner is negative 2q cubed. That doesn't give me negative 7q cubed. And if anybody has the bright idea of saying, well, let's just change this to positive and that will give me negative 7q cubed, what's the problem with that? Yeah, I'm not going to get positive 6 out of it. So it can't be 2 and 3. Well, if I were doing this, I would just stop for a second and say, wait a minute, is it factorable? I mean, we could try the 6 and the 1. But we're going to say, is it factorable? Let's do the b squared minus 4ac thing. Am I right there? I'm just doing this in my head, so I may have made a mistake. Is that right? Well, we'll talk later, but first of all, if that number is negative, there's bigger issues at play here that we'll learn about later. However, that's not a perfect square, so this is not factorable. Bit of a trick question. Any questions with that one? Okay. So on page 9 of your unit handout, there's a variety of questions. They all, this by the way was something I talked about last semester probably. This would be something you would factor in 30-1. But, so you're not going to run into any questions like this in today's practice assignment, but this would simply factor into tangent of x, and I guess negative 4 and positive 2. Can you just run that through your brain and see if that makes sense to you? So what you deal with in 30-1 are quadratic equations that are also trigonometric in nature. And if you were trying to solve this equation, then you would turn it into a Math 20 question where we have tan x plus 2 equals 0 and tan x minus 8 minus 4 equals 0. So that's where we're going with this eventually. Anyway, you can see there's a whole bunch of problems that ask you to factor things. I don't think you need to do everything. But definitely you need to do sum from number 5 and sum from 1, 2, and 3. 1 and 2 rather. Okay. And you can see what the assignment is. 1, 2, 4, 5, 8, 9. But you have to know how to do the stuff in 1 to 2, and you have to know how to do the stuff in 5. The other stuff is just extra. Tomorrow we're going to move on and we're going to look at an alternate way to solve quadratic equations. because the quadratic equations will not be factorable. But they still have solutions.